Hello, my name is Chayton Hogue. This is my undergraduate research project presentation for the Sooner Off-Road competitive team at the University of Oklahoma that is advised by Dr. Chris Dalton. The Sooner Off-Road team builds and designs a off-road vehicle that is competed against other universities and is sponsored by the Society of Automotive Engineering. Some of the project goals of this research was to learn more about the car's required braking force, create a digital tool that would assist future brake design leads in sizing required calipers, maximize caliper efficiency, reduce the net price of brake caliper components, and expand the team's knowledge of components functions in the vehicle. Some project knowledge background that we had before starting this project was two design leads in the 2019 to 2020 year, namely Shane Wyatt and Joseph Grimes, performed research over brake master cylinders for the competition year of 2019 to 2020. This performed as a basis for the knowledge of this research, as it allowed us to know what pressures we would see in the brake lines to the calipers and allowed us for a greater control over the system. How a disc brake system functions is shown in the diagram below. First, someone steps on the brake pedal on the left, which then pushes a rod into the master cylinder, which is sealed off, which causes the fluid to be pushed over to this caliper. And because the fluid is incompressible, once it reaches and pushes this piston up against the rotor, it will start, and the person applies more force, it will eventually cause pressure buildup, which will then result in a clamping force that then turns into a frictional force that stops the rotor. On the rotor discussed previously, there's two different types, namely the fixed or a floating caliper. On the left here is a floating caliper. As shown, when you apply pressure and it pushes the piston out, it causes the caliper body to move, which allows the arm on the opposite side to also meet the rotor, which creates a clamping force. And with fixed calipers, both sides have pistons and pressure is performed on both sides that causes those two pistons to push together, creating a frictional force. With the floating, the caliper body itself moves, and with the fixed, it doesn't move. This is another image of the fixed caliper on the right. As a note, floating calipers tend to be cheaper and lighter than fixed calipers, but fixed calipers tend to have less play and respond quicker. Some things to note as well is that bore size impacts the clamping force as well as pedal travel. So if you have a larger bore size inside the caliper, then the clamping force will increase, but because that bore size is larger, there's more fluid displacement to get that piston to move than a smaller piston would cause. Shown below is a brake diagram for a floating caliper. On the far left is a mounting plate, which is what allows the caliper to be mounted to a car or some other rigid system. Then there's the bleeder screw on the top left, which allows any air or compressible fluids to be removed from the system, which allows pressure to build up. Then there's a seal, which allows the fluid to stay in. The piston itself that slides on the seal, which then pushes the brake pads, seen on the right. There's the guide pins as well as the bushings, which is what the caliper body itself slides on, and also what connects the caliper body to the mounting plate. There's the brake pads themselves, as well as an anti-rattle clip that holds the brake pads in place so that they do not create unnecessary noise. Some of Sooner Off-Road's previous methods was a fixed 1.12-inch bore fixed caliper by Willwood. It, in previous years, locked up all four wheels in brake check at competition. The new floating caliper design process, there was tests performed on the current car to determine required bore sizes. This was done by dragging the car and seeing what force allowed the wheels to be dragged while also being locked up. It was determined from this testing that the current bore sizes on the car of 1.12 inches is adequate. To achieve accurate test comparison results, the caliper's bore size for the caliper design in this research will be 1 inch because we also have 1-inch Willwood PS1s in the shop that can be compared to for numerical analysis. Calculations performed also determined the minimum allowable wall thickness with the pressures expected to be seen. Iterations were designed in SOLIDWORKS and tested against the allowable stress using SOLIDWORKS simulation software with the goal of a safety factor of 2. This was what was discussed previously. The hanging scale shown in the picture is the force found while dragging the car, which was around 420 pounds in each of the testing. On the left is the equations used to find the clamping force, as well as the various other components, such as the bore size that we needed to find. Iteration 1 is shown here. Some of the issues with this design that were found later on were that we were not going to be able to machine the piston seal seen here on the bottom right, because we didn't have any slotting tools that could reach that far into the material with our CNC mills. This initial design also had 2 piston holes. This was later decided not to be used so that we could compare it to the Wilwood PS1 as well, that it would make machining easier. Iteration 2 split the master cylinder in half so that we could reach the piston seal. The mounting holes for the guide pins were added, as well as 2 bolt holes to clamp the 2 sides together. Material was removed from the back, and a spout was added for the brake inlet, and the brake bleeder screw was moved over to this area. For iteration 3, we realized that the guide pins were in the wrong location, which would cause a conflict with the rotor, which is this gray construction line seen here. And the guide pins would be coming out towards us, which would obviously hit the rotor. So those had to be moved. Iteration 3 moved those guide pins mounting spots. It also added brake pads and mounting plates, as well as the guide pins themselves into the assembly. Some more material was removed from the back of the caliper. And iteration 3, we finally performed FEA, where it showed that the highest stress was found at the top of the caliper, where it was being pushed back from the piston force and causing it to push into the caliper body itself up here, creating a stress. And then in the inside of the caliper arm, there was also a stress found in this interior where it was bending. To remove these stresses, we added a 0.25-inch fillet instead of the 0.125 that was there, moved the bolt holes lower, closer to where the force is, as well as added material on the top to reduce those moments. The results of those modifications allowed for a safety factor around 1.5 and reduced the stress massively. However, the safety factor we wanted was a safety factor of 2, and so we're hoping to achieve a better safety factor with more modifications. Moreover, with the current design, there is a pad conflict with the 0.25-inch fillets, so more design modifications will have to occur to get that to work. These are the current design's dimensions: 3.8 inches by 2.9 inches by 3.9 inches. Project update on where we are now is we need to finish current FEA of the pressure and forces caused by the pistons, which is shown earlier. We also need to do FEA on the brake pad holders, as well as mounting plate from the torque caused by clamping on the rotor, which will then pull pads with it. We need to smoothen out the design by applying fillets on all rough edges. We need to order components just as seals that we cannot make in-house. We need to write cam and machine on the CNC mill to create the caliper itself. Then a test rig needs to be created to test the student off-road caliper versus the Wilwood PS1, and also to retrieve numerical values that can then be compared to the industrial caliper. Then, after all of this, the caliper needs to be reevaluated after testing to determine what changes need to be done to the design. Thank you for listening. This is an image of the exploded view of the caliper.